We will start now with the fifth section of this chapter, which is History of the Atom. So let's look at early ideas about atoms. Back in history, the ancient Greeks were the first to have ideas about particles and atoms. However, these ideas were not linked to strong experimental evidence until the early 1800s when John Dalton put his ideas about atoms. From his experiments, he modeled the atom, as you can see here, as a tiny hard sphere. He also suggested that each chemical element has its own atoms which have different masses than other atoms of other elements. For example, atoms of the element carbon have a different mass than those of the element sulfur or any other element. Dalton believed that atoms were the fundamental building blocks of nature, which means that they can't be divided or split. These atoms will rearrange themselves and combine with other atoms in new ways during a chemical reaction. These ideas proposed by Dalton are still useful today and are used to visualize elements, compounds, and molecules, and to describe the different arrangements and movement of particles in solids, liquids, and gases. Let's look now at the evidence of electrons in atoms. One discovery that is considered to be a milestone in science is the discovery of electron at the end of 1800s. A scientist called Thomson discovered the electron and then everything changed. So what is an electron? Thomson's model viewed the electron as a negatively charged particle which is really tiny and have a mass that is 2000 times smaller than the lightest atom. How did Thomson then discover the electron? Thomson was experimenting by applying high voltages to gases at low pressure. So these beams of particles were attracted to a positive charge, as you can see, which indicates that they must be negatively charged themselves, and those are the electrons. These electrons must have come from the atoms inside the tube. So Dalton's idea that atoms couldn't be divided or split had to be revised. And then a new model was proposed by Thomson in which the tiny negatively charged electrons are embedded in a cloud of positive charge, as you can see. Thomson knew that the atom carries no overall charge and thus the positive and negative charges must balance out in an atom. If you examine this model, you will find that there are 15 positive charges and 15 negative charges, and thus the overall charge of the atom will be zero. Actually, Thomson imagined the electrons as the bits of plum in a plum pudding, and then his model was called the plum pudding model. After the evidence for the electron came the evidence for the nucleus. So the next breakthrough in understanding the atom came about 10 years later, when Jaeger and Marsden were doing an experiment with radioactive particles. They were actually firing alpha particles, which are dense positively charged particles, at the thinnest piece of gold foil they could make. Those particles were expected, according to previous models, to pass straight through the gold atoms with their diffuse cloud of positive charge. However, the results shocked them. As you can see, we have here some deflected particles. Using those results, Rutherford said that Thomson's model wasn't possible. And then he developed a new model, where the positive charge must be concentrated at a tiny spot in the center of the atom. Otherwise, the large positive particles fired at the foil could never be repelled back towards their source. The model in this figure was then proposed, where electrons are orbiting around the nucleus, which represents the center of the atom, and this nucleus contains very dense positively charged particles which are called protons.